Welcome to the breakout session on MOM 2005 Architecture and Internals. I am Ashvin Sanghvi. I'm the Architect PM on MOM. I've been with the program from the beginning. And I'll be your tour guide as we look under the hood on MOM. So what we'll cover today is very briefly the feature improvements that are made in MOM 2005 and how, with a view as to how it affects the architecture. We'll go over an overview of the architecture, and then we'll kind of do a deeper dive on kind of theory of operations as to all these new features that have been added, how do they work. It should answer some of the questions you've been asking. So overall, MOM 2000 or MOM as a product, the problem space that it is in operations management. So before we go deeper, with a show of hands, can I ask how many people are involved with operations management? Quite a few. Okay, so if somebody asks you, what is operations management? At the simplest level, people say, you've got a bunch of machines, they're deployed in production, and the job is to keep them running. And somebody hears this and this says, that can't be that difficult. That should be a piece of cake. And here you are, you're kind of thinking and saying, you sound like my CEO. That's what my CEO thinks. We should have the least amount of budget because this is, doesn't sound like a difficult task. And here you're thinking and you're saying, even managing a single machine is not as simple as it would seem. First of all, we don't manage machines, we manage applications. Okay? And then each application comes with a whole set of concepts which are different that you got to understand. And each one of them has its own instrumentation. Each one of them spews events at you like it's the only application on earth. Okay? And it doesn't stop there. It's not just one machine. You've got hundreds, maybe thousands of machines, and they're not in one place. They're spread out all over the globe. And they're on networks that may be reliable, may not be reliable. They're across firewalls. And pretty soon you get to know that it's a more complex picture than you think. On top of it, add the changes that come down the pike. Things are not stable. Machines come, machines go. They get repurposed. So now you've got a team of people handling it. And even there is instability. The instant an operator seems to understand the events, which seem to be written in English, but really they're written in geek. So the instant he tries to understand and knows that, he wants a different job. So you got to churn there, okay? And you've got processes written down on a book as to saying how should what event be handled, and people should be following it, but they don't always. So all this kind of keeps adding to the complexity, and that's why it's such a difficult job. So what we'll look at is how we recognize as much as we can of the problems in the real world and address that in our architecture. A quick look at the MOM 2005 feature set. We're not going to go line by line, but basically we've added a lot of features that you can see right from the product, and you've seen that in other sessions. The big things to bring out is we've got a whole new data warehouse and a reporting subsystem, a whole new console for the operator, different ways of using it. So instead of just looking at alerts, you're looking at state, ways of doing overrides or launching tasks. So there's a whole bunch of stuff added in the product, and it affected the architecture in quite some ways. Then there are things that are not that clear from the surface of things. There are things under the hood that have changed, and that you will see in terms of these other features on the product, like the scalability and performance. This thing has gone up 4 to 5-fold over time on MOM 2005. Internationalization, now we are localized and globalized. Security, a whole bunch of stuff added in terms of mutual authentication and encryption and isolation that helps you run a secure management infrastructure. And we also recognize that we're not alone. You've got a whole bunch of other management products in your environment. So a bunch of investment in terms of extensibility and connectivity into these other things. And we thought we supported a whole set of topologies in MOM 2000 SP1, with the multi-homing, the multi-tiering, cross firewalls. We've added even to that. So there's a lot of stuff added in the product that did affect the architecture. So looking at the architecture internals, the first big challenge that you want to take a look at is you've got a ton of data coming in. In OTG here, you have like 200 million events coming in a day, and you want to get to the actionable items up onto the console. And it's not a problem of replication. Even if we had infinite bandwidth, we won't want, people can't handle with that kind of data. We want to stem it at the source, and we want to make sure that it is, the interesting things come across the wire. So the first thing to look at the architecture is the bottom pieces, where we've got the managed nodes. And the first thing to recognize there is our agents are intelligent, they are autonomous, they look at data from lots of different providers, and they run rules on them so that only the filtered amount of interpreted data goes up to the server. The other thing to look at is the thing right at the top, the DB. We recognize, in fact, somebody was telling me that in an operations environment, sometimes people cannot even come to an agreement as to what the problem is, not how to solve it. And that's because they're looking at different tools, and they're looking at different snapshots of the data, and they're seeing different pictures, and they're just arguing all the time, right? So one of the first things you want to do is make sure that all that data hits a single database so everybody sees the same picture. So that's the thing on the top. All our operational data sits up in the DB. The other thing to look at is managing the management infrastructure. If it is spanning the globe, that itself is a challenge. Okay, and when everything is going haywire, you don't want trouble from there. So we also keep all our configuration down there, and we'll get to see how any config change in the DB ripples through the architecture down to where it needs to be automatically. The third thing, of course, on the side here is the data warehouse subsystem, and that's where we keep the long-term data from the operational DB laid out in a way so that we can do the right reporting and analysis on it. And the things you see up on the side here are all the user interfaces, and we, as Sean told you, we've taken a persona-based look at our UI. So we have different UIs for the knock operator, and a different one for the casual user, which is the more web experience, and a different one for the one who's administrating or changing rules, and a different one for the CXO who's looking at reports. And those are all the user interfaces on the side out here. Now, the thing that is interesting is that the box in the middle, which is your go-between, between the DB and the agents. And that's what we call the MOM management server. And the first piece I want to draw your attention to is this thing called MOM server that runs under the part of the MOM service. So its basic job is first make sure that all the configuration that it gets from the DB gets to the agents as they change. Okay. Also, another thing is to collect all the data and put it efficiently back into the DB. That's kind of the main job of it. The thing on the side, the MOM agent, part of the MOM service, its job is to manage itself, manage the server itself, plus the whole function of agent management is done by that. So, in recognition of your real world where everything is changing all the time, what we do in this MOM agent is discover the machines as they come and go, install agents remotely as they need to be, recognize automatically that what roles or what applications you're running on those managed nodes, and make sure that the right rules and right configuration get down to there automatically. This is all without you having to run around doing things. The other thing that we recognize down again here at the bottom is this node called agentless managed computers. And really what we're saying there is that in your environments, you always have systems where you don't have rights to put your bits on, okay, until the next big change happens, maybe 6 months from then. And you don't want to hold up your overall MOM deployment as a result of that. So for those exceptions, we want you to use the agentless mode to manage those machines without really putting your bits on. There is a price to pay on the server side, but it is a way around that. Also, the DAS layer is your gateway into the database, and everything, all the UIs go through the DAS to the DB. Even the server accesses the DB through the DAS, and it is really a COM wrapper on all your DB access. And it also is a way to enforce role-based security. And then, of course, in recognition of the fact that we're not alone, we've got a pretty robust APIs, what we call, the name here is given an SDK. SDK is just the documentation of the APIs we have in the product. And there's a whole variety of them, right from a web service for doing connectors to a managed code API to doing something more sophisticated. And we continue to support our old WMI APIs, but we are deprecating them. And that's where all the connectors and the third-party stuff connect in. And just to make sure that we provide you the right richness in that APIs, we build our whole web console on top of the SDK. So we don't go anywhere else but those APIs to present you the web experience. Other thing to recognize is the agent and the server that talk across a channel. We'll get into the details about it, but it is the proprietary TCP/IP protocol that on a fixed port, so you can punch a hole through a firewall and work that. But the job of installing the agents or managing agentless nodes, that happens over RPC DCOM, so you cannot do that across the firewall. Looking a little deeper into the architecture, first we need to kind of cover what a rule is, which is kind of your unit of instruction or a policy for monitoring. A MOM rule is made out of a provider, which says, where do you get the data from, a criteria, which is probably the key part of the rule, which says how to look for a match, and a response, which is, what do you do when a match occurs, and then some supporting knowledge so that the alerts and stuff like that we generate from this rule has some information attached to it. And all that stuff makes up a rule. Now, going back to the challenge, remember we said 200 million events, and you want to consume that and create like maybe 1,000 or so alerts out of that. And the way we do that is giving you a rich set of rules which allow you to filter, to consolidate, to correlate information and do this. And they're divided into three major categories: event rules, which operate on event data, performance rules that operate on perf data, and alert rules that operate on alert data. And within that, we have these different types. For instance, collection rules just collect selected events. A filtering rule would look for a certain type of an event and remove it from the stream. And there are three subcategories to that. But at an overall level, it'll remove it from the stream, either prevent it from getting into the DB or remove it right where it sees it. A missing event rule is now looking for something that did not happen within a certain time. A consolidation rule basically looks at a stream of events of a similar type, and you've got a lot of flexibility in determining what the similar type is. And it gives you a first event saying it happened, and then for a period of time, it'll just keep a count and give you one event in the end saying these many happened. Duplicate alert suppression, its job is to make sure that if an alert is already alive, in the DB, and a similar one happens, it doesn't add more clutter. It keeps adding, suppressing it so that it's kind of counted within the unresolved alert. And in perf rules, we've got some two kinds. One is just sample, and one is sample and then threshold. And in both cases, we give you ability to do some pre-processing of the numeric data coming in. And an alert rule's job really is to collect all alerts of a certain type and take a single response for it. So if you want to say, page John when this thing happens, any high severity alerts happen for exchange, you want to create one alert rule to do that so that you're not putting that kind of response all over the place in your rules. So this is kind of your overall rule structure. Now, we have to look at the other side of this problem. We want to be able to do the sophisticated amount of event filtering at the agent while still being a fly on the wall. Okay, we want to operate with very little resources on the agent, maybe less than 3 or 4% of all CPU running in there. And the way we do that is looking at this workflow. So what you see here is multiple workflows, each for each kind of work item or data item that comes across. Alert or, the raw data that comes in is event and perf. And the other things that you see in terms of alerts, responses, or discovery data is something that we generate from the basic first two streams. And what you see, the boxes in this flow, think of the workflow as a conveyor belt of these data items going down. And each node in there is a work node. And the key value of this engine is what we do is for all rules, we've got 20,000 rules. For all rules of a certain type, we collect them and stuff them into one of these boxes. Okay? And what we do with that is that all that magic is in the configuration, which is we take all those rules and automatically create a decision tree, which makes it very, very efficient to look at an incoming event and seeing what the criteria hit or matches. This is almost the opposite of a DB problem, which is in a database, you have a query, one query, and you get a large result set. Here, we've got 20,000 queries, and one result item comes in, and you want to see which query is matched against it. That's the kind of the problem you want to try to solve. So that's what's done inside one of these boxes. Also, these boxes know about each other. So a downstream box signals the upstream box by annotating the data item flowing through. And it continues up to the server, and we'll talk about that. And the order is important too. So you'll be able to think through it, but let's say there's an event processing node here, and if you look at an event processing rule, it says that the event count is greater than 35, do something. How does it know that the count will be ready? Well, that's because the node right before that, the event consolidation node, is incrementing the count for it. So the order is important too. And if, let's say, an event match happens and it creates an alert, it drops a new alert that enters this top level stream. Or if it has a response, it enters this queue here to the response stream. And if you see, the end of all these streams are always communication nodes because the agent ultimately will send data up to the server. This also, the way this thing is structured, helps our developers add more functionality as needed pretty quickly. So for instance, when we did our state monitoring, we had to do two things: discovery efficiently and state monitoring efficiently. And the way they did that was they added this thing called the alert filtering node up top here, which makes sure that if I'm generating alerts which says I'm up, I'm up, I'm up, I'm down, I'm down, I'm up, I'm up, that kind of a stream, we don't repeat that on the wire by filtering it off there. Similarly, for the discovery, we're now collecting a rich amount of data from every node, and to make sure that we don't send this barrage of information, even if it is not changed, we do that efficiencies down here in the discovery filtering node. So all that stuff is built into this kind of an engine. And by the way, this whole structure is repeated for every home the agent is talking to, if it is multi-homed. A very similar structure also applies on the server. One thing you'll note is there are lots of DB nodes there, because data landing upon the server ultimately gets stored in the database. But even here, we do some interesting things. For instance, this group population node would do something like look for a discovery item and automatically automatically repopulate the computer groups, because this discovery means that this machine is not an exchange box anymore. Now it's a SQL box. So you don't have to go type in and say include into this computer group and exclude from there. It's automatic for you. This may be a too deep a view, but this is how our runtime looks like. And it's very similar. What the runtime on the server and the runtime on the agent looks very, very similar. The key things I want to bring out here is the yellow box is the executive. It manages the lifetime of all the other boxes in there. The other key thing is the key item here is this workflow manager, workflow nodes, what we just looked at. Another thing to look at is all our providers and responses run in the action manager out of proc from the agent, so we can isolate any kind of problems that would happen based on scripts that we didn't know about running in there. Same thing up here on the server. A couple other things to point out is we've got this thing called the queue manager that persists all the data while it's going through the workflow engine. So even if you stop the service or turn the power off in the middle of operation, you don't lose anything. We're persisting it at every stage in the game. That's kind of the overall view of things. A little bit look at the channel. A little bit, okay. The channel is a proprietary channel TCP/IP protocol. Default port is 1270. Our heartbeats go over UDP, and it provides all the services that you would expect of a communication channel, like buffering, congestion control, encryption, signing if AD is there. That's what happens on the channel. And one thing to remember is all communication is always initiated by the agent. So server is always in the listen mode. A quick look at the MOM DB. Two major pieces of data in there. All are operational data, which is alerts, events, performance data, and all discovery data stays here. And it has all the configuration data, which is anything that you've done to configure MOM, and all rules that you imported or created or updated here. That stays in this database. And it runs on SQL 2000 in any instance you want, and it supports SANs or clustered SQL database servers. MOM data warehouse runs again on the same kind of SQL incarnations, but the thing to remember there is we periodically transfer the data from the DB, operational DB, to the data warehouse and lay it out in a Snowflake star schema so that it's easy for analysis. One thing I forgot to mention on the DB, which is the grooming. So in MOM 2000, one of the challenges was we got this high volume of data coming into the DB, and we almost have to, at the same rate, groom it out once we reach a steady state. And that was pretty challenging. Sometimes we groomed every hour, and it took 40 minutes to groom. So, it was like 40 minutes on the hour, you're deleting data, because you had to go select the data that you wanted to delete and then remove it. In 2005, what we've done is we've laid out all the big tables, like events and perf data, into partitions by day, with 60 partitions with a view on top. So it looks like a single table, but underneath there are 60 tables. And the task of grooming out data is just dropping a table. So it's lightning fast compared to how it was in the past. A quick look at the consoles. The first thing on the ops console, I don't know, people miss one thing, which is on the ops console, we have the idea of a view type. And there are all these alert view, topology view, status view, all those views are different view types. And instances of that are a pretty rich way of creating instances of it and shipping it within a management pack or creating it at the customer site. And that's what shows up here. Plus, of course, there are multi-panes supported, so you can have more than one view out there. And the MMC console is pretty similar to the past, except we've done a bunch of stuff in terms of streamlining your MP imports and the agent deployment experience. But that is the area about authoring new rules is pretty similar. And then, of course, we've added this web console in the recognition of a fact that not all users of MOM are NOC dwellers, people who live in the operations center watching the screen all the time. They are business managers who are interested in the health of 15, 20 machines, and they just don't want to install a UI, just come over the web and look at that, and that's what the web console is for. So looking at the theory of operations, the first thing, of course, is most of you know about a management pack. Is our delivery mechanism of everything that we need to do to configure MOM to go manage some technology like SQL or Exchange or something of that sort. And as we've added new concepts in MOM 2005, we've added new pieces for it in the management pack. So now tasks sit in there, and schema sits in there, and everything that we've added, like topology definitions and bitmaps for showing the topo, all that stuff sits inside a management pack. And logically, a report is also part of a management pack, except it resides in a separate file. it's still, we support the .akm binary format, but it's also expressible in XML for analysis purposes. So you can export a management pack and do diff and interesting things of looking at a management pack in the XML format. And we'll cover that in our tools discussion. The other big concept introduced in MOM 2005 was nested computer groups. In MOM 2000, we had a rich concept of a computer group. It was dynamic, it was self-populating, it was intersecting, it was your targeting mechanism. But what we added to that was the nesting. So you can, computer groups can contain other computer groups, and this way people can, organize their geography or their organization in a certain fashion. This, of course, means it is a polyarchy. A computer group can have more than one parent, and we use it for everything from targeting overrides or targeting rules or scoping, that is, showing only a subpart of the world to a particular operator. All that stuff is based on nested computer groups. So one thing for the people who've already used MOM, I want to clarify something, which is this thing about how does a rule get to a computer? How does this targeting work? And how sometimes the enabling, disabling gets a bit confusing. So let's say I've got this world here. I've got this green things are computer groups in a nested set of computer groups. And on the blue things are rule groups. We used to call the rule groups in the past a processing rule group, PRG. We're just calling them RGs now. So now your question is, this rule here, how does it get to this computer? Well, if I've associated a computer group to a rule group here, this rule will hit that computer, okay? But the way the rule groups are organized are for many purposes. It's a container, so this top level rule group here is just for containment, so we can export a management pack together. While other rule groups are for organization, other rule groups are for targeting. So this particular one here is for targeting, okay? So if people have tried and they'll say, well, I'm disabling this rule group. I expect this rule to be disabled. Why is it not disabling? Well, look at that. The connection is still made. Okay, the rule will still hit the computer even if the rule group is disabled. What you want to do is either disable this rule group or disable this computer group. And if you do either one of these, this connection will be broken and that rule will not hit that computer. The next thing we introduced in MOM 2005 is a first-class object which is other than a computer. So in the past, only the computer had events and alerts and state associated with that. Now what we did was we introduced the concept of service discovery and of a concept of schema, and in which we can represent classes and relationships. And we persist that and express that all the way from the management pack to the DB to the data warehouse. And we use this for many, many things, for state monitoring, for topology monitoring, for targeting tasks, and so on. And a class is like any other class. So something like a SQL Server role would be a class. A relationship would be something like this domain controller replicates to that domain controller. Okay? And relationship generally points to two classes, one where a source has to be and one where a target has to be. Both of them can also be the same class if you want. So one of the biggest problems people run into when they get into this kind of a situation is a priori, we don't know all the classes we'll have to support. As we import more and more management packs, everybody wants to introduce new concepts, right? SQL MP wants to deal with a SQL Server, a SQL instance, a DB, a stored procedure, a SQL job. Those are his objects. Exchange would want to have things like, their protocols and their stores and so on. So there is a large number of classes that we want to support without an explosion of tables in the DB. And the way we handle that is what we call the MOM meta-meta model. And what it really does is allows you to first look at the simplest way of looking at it is look at these top 4 tables. Okay, these store a single row for a single class that you want to introduce. So let's say a class definition here would have a single row in there expressing I've got a SQL class. An attribute definition here would have a single row in here saying I've got a property of the type size. Okay, A relationship definition would have similar rows saying there is a relationship type of containment or replicates or something, trusts or something of that sort. And relationships can also have attributes. And the blue tables actually have the instances that get populated in your environment automatically through service discovery. So this way, with a few set of tables, we can keep adding new things that we can discover. And how does that work, the population part? We introduced this idea of a service discovery rule. It's not a new rule. It's just something that can be triggered by an event. Mostly it is time-based. And what it will do is it will call a script. And the script does everything required to go discover these instances in whichever way possible. And then it will call our object model to insert what we call a discovery data item, which will then populate the database. One thing to remember in that discovery data item, every item that goes up is updating a small part of our discovery database. So it tells you that I am talking about this class, these few properties, and in this scope. I'm only talking about things in this SQL instance or things in this computer. And if that is different from what you've got up in the database, update that, as long as the timestamps are good. Also, not to forget that we used to do some of this in the past. We used to discover computers and their registry key-based attributes. Those just become special cases now of the discovery. Is encompassed in here. So just a quick look at the scripting object model. All these discovery interfaces you see back here at the bottom, those are the things that you use within a discovery rule to populate these instances. So if you have to walk through the steps that we'll go through for this, right from discovering agent to full discovery, this is what you would do. Let's say a new server, number one, a new server is added to the domain. A scheduled discovery would go find it from the Active Directory and put it in the database. Now, if it was set for agent manage, the mom server will go install the agent bits on it. That's step 3. Step 4, now agent starts, and right now we don't know anything about it. So it just says, hey, give me my configuration, and the mom management server will give it a standard set of rules which says just read your basic registry keys that I'm interested in. So that comes up, and it gets stored in the database. So one thing to remember is the management server keeps asking the database, is there a new configuration every 5 minutes? And every agent asks every 1 minute, is there a new configuration? So the next time, now that I've got the reg key information of the agent in the database, okay, now I can classify them automatically. And I recognize this is an Exchange server, let's say. So the next time the management server asks for the configuration, it gets a different configuration for this agent because now we know it's an Exchange machine. And next time the agent asks for it, we'll understand that it's an Exchange server and send it down all the Exchange discovery rules. So now that data starts flowing in, and now we've got all the information about Exchange in it. And if you actually observe it in a running system, you'll see after a few minutes, you'll see this transformation from knowing that it is just a computer to knowing it is an Exchange server to knowing that it's got these Exchange stores and protocols and so on. Also, one thing which is good in terms of ease of operation is though the agent installation across firewalls is manual, that's a one-time thing. After that, all the service discovery information flows across the channel. So we are automatically classifying them even if they are across the firewall. Quick word on state monitoring. How does that work? So you've seen the demos on the lights turning green and red automatically, and the classification as to what are the roles of running on a server and what are the components on it. How does all that stuff work? Same thing, of course, in topology, which we show you state live. The way this thing works, it's all based on service discovery. So after recognizing that we've got all these roles and instances, the next thing we want to do is turn these lights red and green. And the way we've done that is using the alerting infrastructure. So the alerts are extended so that instead of just pointing to a fact that is from a computer, it can actually say, I'm from this computer, I'm from the SQL role, I'm from this SQL instance, and I'm about the SQL agent component. So you can very, very sharply target what an alert is about. Plus, we've extended one property on it which says what is the current, it's called the problem state property. It indicates whether the problem is active or inactive, and for backward compatibility, it says investigate. In the past, all we could do was generate an alert, and a human had to go investigate and resolve it. after confirming the problem is gone. While for all these new state alerts, they're automatically telling us is active, the problem is active, well, it's gone inactive. Okay. Also, to create these kind of rules, we've added more support in the MP creation, which is advanced threshold rules. We do some internal event generation for service status change. So with this set of stuff, it's a bit easier to do state monitoring. Also, we'll resolve automatically with a job any alert which is turned green, but we keep it there for a while, at least so people know a problem has occurred. And somebody can turn off that policy if they want to go through every problem, even if it's self-resolved or self-turned green, to keep a record of it. The big thing to understand, of course, is roll-up. So let's go to the next slide to see how that works. So this kind of a computer group contains computers, that contains rows, which then contains role instances, which then contains components. And I'll explain this idea of an alert bucket, but ultimately alerts are pointing to the components. And at the bottom level, all these, up to the computer, what you'll see is we go by the logic of worst case severity. So let's say I've got alert which is already inactive, resolved. I've got 2 active ones, one warning and one critical. That thing will roll up to this bucket here as a red alert or a critical alert. Now, what's an alert bucket? Remember, we did duplicate alert suppression for doing the state keeping, and there's a use for it. So let's say I've got a component called protocols in Exchange, but within that, I want to track 2 different protocols, MAPI and SMTP, let's say. I can duplicate alert suppress those alerts differently and keep track of these 2 things separately and make sure that I can keep state, and I know that MAPI is red, but SMTP is green. And that turns this guy red, the component, the protocols. That turns the role instance, which is Exchange, red, all the way up to the computer, that's red. Actually, this rolls up all the way up to the computer group too. It's just shown in a different color because we can be more sophisticated about roll-ups in the computer group. So we can do things like percentage-based roll-up or something of that sort up to the computer group. And it is only calculated when you ask for it. How do tasks work? So first, tasks are user created or they are imported automatically from a management pack. And the basic idea is you are in the UI, you point to one or more objects, and you fire off a task, and that's what the user sees. But internally, there are 2 kinds of tasks. One is the console task, which is kind of simple. Basically, it is just running something under the user context on the console, and all it's doing is picking up some parameters from what you've pointed to. That's all there is to it in the console task. But the idea of a console task is it helps you create a quick way of creating UI-rich experience on the console, pointing to the problem that you're looking at. The thing that we've added a lot of infrastructure is the runtime tasks. And those can run commands or scripts or managed code, but they'll run at the server or at the agent. And in fact, at the creation time, you can say, I want this to run at the agent or the server, or the third category, which says you decide. Run it closest to where the action is. If it is agentless, run it on the server, otherwise run it on the agent. That's the third category. Okay. The runtime tasks run under the action account, and though you pointed at a few objects like computers or alerts or events when you triggered off the task is targeted to a specific class when you author it. So you can say this is a defrag drive task, and it is targeted to drives. And because we have the drives in the database, we will go enumerate all the targets, and that's what we'll go operate on. So, and then of course there is some status generation that we do for it. So, looking at how the internals of it works. In fact, let's just look at this workflow here. So, let's say a user launches a predefined script to be run on a bunch of computers. What we will do in step 2 is the UI will go to the database and for the set of computers, look at all the things that have to be targeted. I don't know what, let's say it was targeted to drives. Okay. So it'll enumerate all the drives that you want to run this script against. And now you have a choice of picking the drives that you want and not, overriding for the ones that you don't. Now what the UI will do is find out where are the computers associated to in terms of, because there are more than one management servers, they'll find all the management servers for these items, and actually it'll create a set of strings, each one for one task. Okay, so one drive with all the right parameters on it, and pass that to all the management servers. And from there, the management server takes over. So if what it'll do is it'll find out if it needs to be run on the management server, that's where it runs it as a response. If it is to be run on the agent, it'll add it to the agent configuration. So when finally the agent asks for its configuration, it'll get this task to be inserted into its response queue, and it'll run it there. And by the way, the configuration is a pretty expensive task, so we don't reconfigure the agent over and over again every time you have an agent. We have a special path for it. On the reporting side, really, almost all of the reporting subsystem is SQL reporting service, but what we want to look at is the way things are laid out in the data warehouse. So almost anything that of interest is laid out in this form of a fact table and dimension tables. Almost all the fact tables have dimension tables like date, time, computer that is associated with. And then there are some special tables that make sense for that kind of data. So let's say I've got an alert fact table here, and it is associated with a dimension of which rule created this alert and data about that. This table here is an alert history table, and it has special dimensions like which user added a history, change resolution in this alert, and what did it resolve it at. So now I can create reports here which says, like where are we taking, stage 1, stage 2, stage 3 in escalation, where are we taking the longest time for a certain type of an alert. You can do that from these type of layouts. Same thing we do for event fact table or sample numeric data table, and there are other tables like that. The other area to cover is agentless monitoring. So again, we recognize that there are machines that you can't touch and can't put bits on it, but from every other way, we want it such that the operator sees no difference between a machine which is running agentful or agentless. And we also wanted to make sure that even the MP author doesn't see the difference, and we've achieved it to a pretty high level, but there are some limitations. The limitation is there are a couple providers that we don't support in agentless mode. The WMI provider and the app log provider, and a couple of responses, the file transfer responses, and any script or managed code that cannot be remoted, obviously will not be able to run in the agentless mode. But otherwise, even for the MP author, it's an identical experience between an agentful and agentless node. And the way that works is the MomDB keeps track of which Mom server is responsible for what managed nodes, regardless of whether they've got agents or don't have agents. It'll send all the configuration over to the management server. The management server, if it's got an agent for it, it'll make sure that the configuration reaches the agent. Otherwise, what it'll do is it'll tell its local Mom agent. On the server, there's the Mom agent, and that Mom agent proxies for all the managed nodes that don't have agents. Okay? And it makes sure that they're isolated. It runs different workflows for each one of them. And then for all the data that it needs from the providers, it makes remote calls and gets the NT event log data or perf data or whatever it needs remotely. But otherwise, the whole execution of the engine is identical except it's done on the server, not on the agent. And then, of course, as it is sending data up to the MomDB, it's making sure that the sources are right. So we know this alert is for that agentless node and not from the Mom server. The other big concept we've introduced is overrides. So one thing we do well is get people time to value really fast, because after you install a Mom server, you import your management packs and you get value right away instead of writing a whole bunch of scripts or rules that our competitors need sometimes. But one of the problems with that is there are exceptions. One size doesn't fit all. You always have some exceptions, and the exceptions generally fall in the category of disable this rule for this machine or this set of machines, or change the threshold for that set of machines. And in the past, you could do that, but for that you have to create a new rule targeted to that set of machines, which pretty soon becomes not very manageable, because you can have a whole bunch of copies of rules with different thresholds and so on. What we did with overrides is you keep the rule intact, and what you overlay on top of is an override. An override and it does these things, either changes a script parameter or a threshold or enables or disables a rule. And it can be targeted to a computer group or a computer. And MOM takes care of all targeting and conflict resolution issues. And it's exposed in the UI, it's also exposed in the SDK. So how does that work? When the MOM management server constructs a new engine configuration for an agent, it also enumerates all the overrides that apply to that agent. And it sends down the winning sets. And the winning is based on the order of precedence of an override. An override is nothing but a name-value pair as far as the configuration is concerned. So this set of overrides now land up on the agent. And the agent otherwise gets the right set of rules and is merrily chugging along, going through the workflow processing. But let's say in this situation, a script is overridden, some parameter on that is overridden, and a criteria match occurs and the script gets launched. The first thing the response manager will do is say, oh, here's a script. Maybe the parameters are overridden, so it asks the configuration manager for each one of the parameters if there's an override. If there isn't one, it'll use the default. Otherwise, it'll replace the value and run it that way. So that's how the overrides work internally. But the nice thing here is you can, with a few set of selective targeted overrides, you can have a whole different set of experience on different agents because they combine in the right way, because computer groups intersect. A computer can belong to more than one computer groups, and depending on the overrides that come down, it behaves in the expected manner. The other area of investment is our agent itself is now much more cluster aware. So the MSCS cluster server, we used to call it the virtual server in the past, it's also a first-class object like a computer. It'll show, it has rules that are associated to it, events and alerts are associated with it. It shows up along with every other computer. It shows up in the state view and so on. And the way we do that is the agents on the hosting node does a bunch of heavy lifting for us. So for one thing it'll do, it'll go discover all the virtual servers or MSCS clusters running on it. It'll make sure that it heartbeats for all of them. It makes sure that the discovery of these things, these entities, bubbles up to the MOM server. Make sure all the attributes are going up there, and then make sure that if it is active, it is running the rules for them and sending up the events and alerts and perf data for them. In the area of heartbeats, there's a whole bunch of improvement. First, as I said, this runs on UDP on a very lightweight protocol, so we can do it very, very often. I think default is 10 seconds. So every agent is heartbeating on their own. The server, as I said, always listens, but there is a settable parameter as to how many intervals do you let go by to at least look for one heartbeat from an agent. So when the communication manager on the server finds that a heartbeat is missing from a particular agent, then what it will do is try and ping it. And based on the results, it will categorize the problem as, well, I can ping to it, the machine's up, but the MOM service is down. Or, hey, I can't even ping it, the machine's gone off the net. And based on that, it will generate different events. And now, from that point onwards, we process it, so we make sure that something called a MOM management pack looks at it and shows you whether the heartbeat is on or off for that machine. Also for nodes that are not necessarily heartbeating, like an agentless node, we put that responsibility on the MOM server, who then pings it regularly. So you get a heartbeat from an agentless node in that way. And for a virtual server, MSCS cluster server, the hosting agent sends a heartbeat, as I said before. A bit on topologies. So MOM continues to support all the old topologies that we had, failover and multi-homing and so on. But one change we made is in multi-tiering. So multi-tiering was a way by which there was a MOM management group which was reporting to a higher tier management group. And what we did in the past was forward alerts. On the top level, you see all the alerts coming from all the what we used to call the zone layers underneath. This kind of is generally used for geographically distributed or global distributions of MOM. So what we've done here is this forwarding is done over a MOM to MOM connector using the MCF web services that we have. And what we forward up there is all the alerts plus all the service discovery data. As a result, because we send all the service discovery data, you've got a much richer experience even at the top tier. So what you will see up there, you'll be able to see topologies cobbled together from multiple lower tier management servers, alert views, computer views, and even the group memberships can automatically work because we have all the attributes collected upstairs. What will not work, and by design, is things like events and perf view. We don't want to send that stuff upstairs because that is basically go counter to the scalability requirements on multi-tiering. And of course, we don't want to reach out and run a runtime task from the top tier. We'll not support that. You can continue to do UI tasks because those are just things that run on the console from the thing that you're pointing to in the UI. So that's basically the overall tour of the internals. I just want you to take the following takeaways. First is, as you understand this thing more, we also have a documentation on this overall MOM 2005 architecture that will be available on CDs for all the attendees. And as you understand this more, you'll be more confidently be able to design your deployment plans or diagnose problems or give the right recommendations. Questions?
Going back to the DMZ across the firewall, it's a large improvement of what we had before. So once I do install an agent manually, are there any limitations on what agent manager can do with that over the life of an agent across the firewall?
There are some limitations. Okay, so as I said, once the agent is deployed manually across a firewall, as the discovery data of that machine changes, we change the rules on it, so that works. Agent targeted tasks work because they go down the channel. But let's say the agent version changes. We will not be going across the firewall and updating the agent version because we can't. We still have needed RPC access. So those are limitations that you still have to live with.
I was just curious on knowing why the WMI provider was disabled for agentless. When you cannot install an agent
Yes.
on some managed node.
We're still working through that, but one of the issues was it would require us to remotely subscribe for a WMI event, and as WMI service itself goes up and down, for older platforms, the subscription used to die, so it was unreliable for that reason. There is a work that it works for the newer platforms, but we wanted to again make sure that regardless of the set of platforms you've got, the experience shouldn't bring that out as it'll work here, it won't work here, kind of a thing.
For the you said that computers essentially contain roles and roles essentially contain components.
I didn't understand. Can you repeat?
You said that computers contain roles and roles contain components. Is there anything in the system that says the association between components within a role?
Yes. So the question is associations between components, like this NIC here is running this protocol. That would be an association. Yeah. So there is underlying support for it. It's not exposed in our views and so on. So that is one of the things that we will do further investments in.
If Heartbeat is going now over UDP, how the rules are pulled up back to the agent? It used to be every 300 seconds there was a ping, there was a heartbeat to the DCAM server, and as a result, the agent pulled,
Okay,
gets
good
all
question.
the new
Good
rules?
question. I think I understood the question. The question is the relationship between heartbeat and getting configuration, or getting new rules at the agent. Okay, these things are separated now. Heartbeats are just lightweight heartbeats of I'm alive over UDP, send and forget, and it happens much more rapidly. There's a separate request from the channel, TCP/IP, which says, give me my new configuration. That happens every 1 minute. And so we've separated the two.
And then you said that the service discovery is going through a security channel, right? What about group population? Is still going through RPC, scanning registry, and these kind of things?
Oh, good question again. So in the past, we used to reach out with RPC and read reg keys from a managed node to understand, what computers it belongs to. Now, that is just part of the service discovery. It comes across the secure TCP/IP channel, across the firewalls if that's what you're doing. And the group population is based on that. Plus, it is extended. So now group population is not just based on reg keys. It can also be based on other attributes of the computer class. And the other attributes could be coming from elsewhere. It could be a WMI query, it could be a result of a script, what have you. So you can have much richer ways of creating computer groups.
But the good feature, let's say, of Windows of MOM 2000 was that you were able to get inventory which servers you got prior installing the agents, so you are not able to get this list anymore.
You will actually get a much richer set of inventory-like data.
But you had to install agent prior.
I'm not understanding the question.
So first iteration of scanning was scanning all computers and register and populate groups. So you will be able to find out how many Exchange server you have, how many SQL servers you got, and so on and so on. So you are not able to get this information except unless you install the agent now.
Yes, that's true. That's true.
Okay.
The question was, in the past, the decision of installing an agent or not was based on the reg key information that we picked up before even we installed the agents. Now, we're asking people to make the decision on installing agents a priori, and that's how most people do that. They have an environment that needs to be managed regardless of what it's running.
In the process of discovering services, is it visible somewhere in which state the discovery is? We are processing first server of 33 server and so on. What's happening with discovery, on which stage I am right now, and so on?
Status.
Yes.
So as you run discovery, we've just introduced, yes. In fact, there was a demo yesterday that showed status of discovery and agent installation as it went through in some detail. It is going to improve between now and RTM. Yeah.
Yes.
Sorry, just to add some more clarification to your question. There's actually two modes of discovery. There's a computer discovery, and then there's a service discovery.
Yes.
The computer discovery is where we have the status that you're asking for. That's still sort of done the same way as it was being done in 2000, in that you go ahead and you find the appropriate machines, etc., and you populate the computers. The service discovery aspect of it, the registry attributes do still exist. So if you have that, and they're still defined, and you want to choose that method of doing service discovery, that's fine. It'll still work. You can still get the Exchange attribute remotely. You can still do computer group population the way it was being done. However, that's not really, just from an architectural perspective, right? You really want the Exchange management pack to own the Exchange service discovery aspect of it. You don't want the MOM product tied into what Exchange believes is the way to kind of see that these things exist on the box. Same with the other applications. And that's the model you want to move towards. So that's the reason it was pushed down into the management
What
packs.
I meant with the discovery process is how do I know that discovery process finished? Do I get some result, some
So
feedback?
in the case of service discovery, there is no status. That's slightly unfortunate, something we're working towards.
Just fire up and wait.
It's the initial part of, it's kind of part of the whole rule targeting, where basically all the management packs have a service discovery component to them, which determines the next set of rules that go down appropriately to the agents. And that's the real value add.
Okay, and since there is a lot of changing, a lot of rule changing, right? In the past, every agent download all the rules when one of the rules have changed, right? Is it now something's changed here, some differential download or something?
No, there isn't, but only the applicable rules for the agent will get downloaded. So for example, if you won't download the SQL rules for a box that does not have SQL Server installed.
Okay. When the agent, for agentless computers, you said that this role of agent takes the MOM server. Can this role take also some ordinary agent? Let's say if you have DMZ, and if you want to do all discovery and all these things through RPC, because on DMZ server you're supposed not to install agents.
Okay.
So, but
Good.
also on the firewall port are closed. So,
If I hear the question right, you're saying first, can we just do agentless monitoring and understand more about the machines and then choose the set of machines from there to install agents on? Yes, you can.
yeah, for alert forwarding, is it service information? Are those information forwarded anyway without alerts? Because in case of alert forwarding, only the information that was connected to alert were forwarded to master. What
Yes.
about service information now?
Very good questions. In the past, all we did was forward alerts. And if the alert was pointing to a computer, we figured out there was a computer down there that we added to the database. That's how we discovered. Now, whether there are alerts or not, we'll send all the service discovery data upstairs. So yes, you don't have to wait for a machine to fail before you know the machine exists.
That improvement in the discovery process, does it mean that I will not need to run the remote registry service anymore on the computer for the discovery to work? Before, for the discovery to work, since it was going through the RPC and doing the registry reading, I was basically required to run remote registry service in order for the whole thing to work.
So after the agent is installed, you don't need any registry, remote registry access. But if you are push installing agents, you'll need the access to do a few things. But after that, no.
Well, I understand I will need the access to the admin shares just to push the code. But is it still going to scan? Well, it's still going to scan the registry beforehand. Okay, thank you.
Yeah, could you expand upon the idea of the configuration groups with respect to MOM 2005 and help me understand whether or not there's criteria or reasons to have different configuration groups? For example, you may have had Exchange servers kind of live in their own group. Is that those kind of things?
So is the question about computer groups or configuration group? The configuration group now we're calling the management group, and it is more to do with 1 DB, a bunch of servers, and a set of managed nodes. And the managed nodes could be a mix of all kinds.
So there's no criteria or recommendation as to when you might want to minimize those, or,
Okay,
or
so-
keep them
Okay,
separated.
so from the management group perspective, really what you want to do is have the minimum number of management groups as possible, because every management group adds overhead in terms of maintaining the database, configuring it, importing rules, and so on. So try and go to the minimum number of management groups as possible. Now, where do you have to break out from that mold? First, if it's scale. If you have more than 3,500 nodes, we can't do that in one management group. You'll start doing multi-tiering there. Second is topologies. If you've got, large number of machines spread out across the globe, it might make sense to have a whole management group in Asia or Africa or something of that sort. But even there, if the numbers are smaller, we would first tell you to try and remote manage those machines across firewalls or WANs. If the numbers are a little bit larger, we'll tell you to put up a mom server remotely and still have it in the same management group. Only when the numbers get pretty large is when you want to do that. The other area where people want multiple management groups is when the IT departments themselves want isolation between each other. So let's say the security group wants to control their own rules and look at their own data, while the availability and performance group wants their own. Then we do what we call multi-homing, where you've got two management groups, but they can choose to share a common agent on a managed node. There is a whole talk on both the installation upgrades and all these complex topologies in good details with good diagrams and so on from Travis that you can attend for getting more data on this.
Might be a little overkill, but will the MOM database now support active clustering for the MOM server itself?
This was an ask, and we have not been able to meet that requirement. So we do not support active.
Will the MOM database have to be in the default instance of SQL still?
No, you don't need to be on a default instance of SQL.
In the rule groups where you're talking about the overrides, is that work regardless of whether it's in two separate rule groups, or do the overrides have to be in one? And a case in point may be, I want to notify the application owner if disk space goes above 80%, but I want to notify the server group if it goes above 90. If those are in two separate rule groups, will I have two separate thresholds?
Okay, so I think the scenario you're talking about is there are a bunch of rules. Let's say they're monitoring an application, and if an alert happens during the daytime, you want to tell one set of people, and nighttime another set of people?
That'll work too.
Yeah, okay. For this, there is no overrides really required. All you need is two alert rules, okay, that are configured to look for that set of alerts from that application. And one is to email or page one party, and another to email or page the other party, but they are on different schedules. Every rule can have a schedule, so you can say, Monday through Friday, 9 to 5, this rule is active, the other time the other rule is active.
What if I want them to run at the same schedule? I have an organization where a set of people are responsible for the servers, the operating system, the hardware, and are going to take care of that, and a different set of people are responsible for Exchange.
Okay, so again, this is not necessarily an override problem, but you could do it with overrides too. So let's kind of go down the overrides path now. So in this case here, there would be, let's say, a rule, which is looking for all alerts from... Are you saying the two groups share the same computers? Yes. Okay, if that's the case, it's not an override scenario. It is, again, alert rules. Alert rules can say that only if alerts happen from this rule group, I want to alert so-and-so. So one alert rule sitting in the exchange, let's say if the application is exchange, the alert rule in the exchange rule group will look for all exchange alerts and notify that party, while the rule sitting in the operating system rule group will be reporting to the other party. One more question? Okay.
Can I multi-tier in a multi-forest configuration? So essentially untrusted domains.
Yes. The question is, can we do multi-tiering across forests? Are the forests trusted, untrusted?
No, untrusted.
In either case, we'll actually support it because, remember, we do now alert forwarding across MCF, and that's a web service. So as long as we can set up certificates or something between the two parties, we don't need anything else.
Will I be able to copy whole rule groups to a new rule group? Right now I'm limited to copying one rule at a time in the MFC, and I have to rename it. And is it, copying rules from one rule group to another, or copying entire rule groups going to be easier?
We do support copying and pasting a rule from one place, like one group to another. It'll be re-GUID, it'll be a copy of the rule with different IDs.
But today it's a single rule.
Okay.
I can only copy one rule at a time. Can I copy multiples or a whole rule group?
Travis, you have an answer? Yes, Travis does an answer here. You can multi-select rules and copy them now.
NetIQ has a security XMP, and as you know, it can be very complicated and for security groups to monitor who logged in when and where in a very large forest domain environments. Will you have something similar in MOM 2005? A security management pack or something that help correlate those login events and who logged in when and what and to what?
Okay, so the question is more of a management pack for security, and there are lots of different aspects to it. So we've got a MBSA management pack that will tell you everything about, what machines are out of sync in terms of required patches, where you have vulnerabilities, and so on. The rest of the security management pack type of rules are spread across all other management packs. For instance, the AD management pack has got a bunch of rules that look at, that you would fall in the category that you're talking about in terms of account changes or object changes and so on. I'm not very sure. There is some other discussions going on as to where this set of rules will reside, which is tell me who logged on where at what time kind of a thing. But it is something that could be done with a management pack.
Have there been any changes in the way MOM manages SNMP devices? How can we use MOM 2005 to manage SNMP devices?
The SNMP device support is about the same as where we were in 2000. And so we can listen for SNMP traps, or an SNMP collector can send all the SNMP traps to us through a single path. But other than that, there hasn't been any further work done in that area.
In relation to the SNMP traps and doing custom MPs and state views, is the class schema extensible from a customer's perspective?
Yes, so we're open to any partner who wants to bring in network management stuff into MOM to house their classes and their relationships required for SNMP-based monitoring through MOM. And we'll extend the schema for that.
What about us, the customers that aren't vendor partners?
We can talk. Okay, thank you very much.